let's go ahead and solve the system of equations using the substitution method. And for the very first question, I noticed that in the first equation, y on the left-hand side has been isolated. And I noticed that there's a y on the second equation right there. So what we're going to do is we're going to take this y and replace it with that y. That's the idea of using the substitution method. So if I had to rewrite the second equation, I get 2x minus y equals to 4. And this part right here, this y is equal to all that. So if I now make the substitution step, I would now write 2x minus, and using a different color here, instead of writing down y, I'm going to write negative x plus 2. And that's going to equal to 4. And then from there on, you would just solve for the x variable. So this will be 2x. And then if I distribute that minus sign through, I would get plus x minus 2 equals to 4 on the left-hand side. And now let's collect like terms. 2x plus x is going to be 3x. Minus 2 equals to 4. And then from there, I can take this negative 2 to the other side. So I have 3x equals to 4 plus 2, which is going to be 6. So I get 3x equals to 6. And then divide both sides by 3. And x would equal to 2. All right, so once you find the value of x, you can go back and find the value of y. Now, if you go back to your original equations here, you can use the first equation or the second equation. Let's just go ahead and use the first equation again. So I know that y would equal to negative x plus 2. That's the equation there. But we have already determined that x would equal to 2, right? So we already established that. So let's go back and substitute that in now. So y would equal to the negative sign, and x will now become 2, and then plus 2. So y would equal to negative 2 plus 2, which equals to 0. So my answer is 2, 0. And that's just kind of a wrap up of how you would use the substitution method. So a fair bit of algebra steps here, and just make sure that you're okay with every single step that you're making there. Okay, let's go on to letter 1b here. The good thing for 1b is I see an x over here, and on the right hand side I have 3y plus 2. So what I'm trying to say here with this very first equation is that x has been isolated, right? It's all by itself on the left hand side, which is great. So on the second equation, I notice that there's an x there, right? So I can replace this x in the purple box with 3y plus 2. So let's go ahead and do that. So this x will now become 3y plus 2. And then we just copy the rest of this stuff down here, right? So the minus the 2y equals to 5. And now we can collect like terms because we have the y variables now. So 3y minus 2y is going to be 1y. So that'll be just a single y. And then plus 2 equals to 5. And then go ahead and just solve for y by moving the 2 to the right hand side. So that's going to be 5 minus 2, and y would equal to 3. All right, now that we know that y is equal to 3, let's go back and solve for x. Now, it doesn't matter what equation you use, but I will go ahead and use the first one here. So I know that x, if I just rewrite the first equation again, I get x equals to 3y plus 2. And I know that this y equals to 3, right? So x would equal to 3 times by 3, and then plus 2. So x would equal to 9 plus 2, which equals to 11. All right, so my solution is going to be 11, 3. So this is your x value, and this is your y value. Okay, so we move on to the next one here. All right, so I have 3x plus 2y equals to 0 and x minus 3y equals to 0. So when you're doing these substitution problems, you want to isolate for one of the variables, and you have to figure out which equation would make that step easier. Now, if I take a look at my second equation this time, this one is a little bit easier to work with because all you have to do is move this negative 3y to the other side. If I do that, I get x equals to positive 3y. Right, so in one step I can isolate the x variable by moving the negative 3y to the right hand side. All right, now how does that help us? Let's take a look at our first equation, and let me just rewrite it over here again. All right, so there's my first equation, and anytime I see an x here in blue, I'm going to replace that with 3y, right? Because this x is the same thing as that x right there, so let's just replace this 3y with that x. So if I do that, I get 3, and then bracket 3y, and then plus 2y equals to 0. Right, so there's my substitution step, and 3 times 3 is 9, so this will be 9y plus 2y equals to 0. 9 plus 2y, so 9y plus 2y is going to be 11y equals to 0. And from here on, I mean, if you divide both sides by 11, great, those cancel off. So y would equal to 0 over 11, which is just 0. So y would equal to 0. Now, if y equals to 0, I mean, you can simply plug that back over here. So I know that x equals to 3y, but now we know that y equals to 0. So 3 times 0 is 0, so x would also equal to 0. So my answer to this question is going to be 0, 0. Okay, let's move on to the next one here. Okay, for the next one here, I have 3x minus y equals to 5, and I have negative 3x plus y equals to 5. Now for this one, I don't think it really matters which equation you use. Let's just go ahead and use the second equation just for practice here. What I noticed in the second equation is that I can isolate for this y variable by moving this negative 3y. So if I move this negative 3y to the right-hand side, I would get y equals to 5 plus 3x. I'm going to box that right there. So y equals to 5 plus 3x. Perfect. Okay, now if I take a look at my first equation, I'm going to rewrite that as 3x minus y equals to 5. And just like the previous equation, anytime there's a y here, I'm going to replace that now with this y over here, which equals to 5 plus 3x. So this 5 plus 3x is going to replace that part right there. If I do that, I get 3x minus, and I'll put this in a bracket here because 5 plus 3x is 2 terms, so that'll be 5 plus 3x in brackets, and then equals to 5. Now, one of the reasons why I have put brackets around the y, where y is now 5 plus 3x, is that because I can distribute the negative sign onto the 2 terms, right? So if I do that now, if I do that correctly, I get 3x minus 5 minus 3x equals to 5. Okay, and you'll notice that this 3x and that negative 3x, they cancel. This has 0, then minus 5 equals to 5. 0 equals 2, and if I bring this negative 5 over, I get 5 plus 5, which is 10, so 0 equals to 10. Now, we know that 0 does not equal to 10, so this is no solution. Okay, and what no solution generally means is that if you were to graph your solution, for example, it would just mean that the 2 graphs would never intersect. Okay, so there's no intersection point when you graph those 2 equations. Okay, let's move on. All right, so next one, y equals to negative 3x minus 8, and y equals to 50 minus 2x. Okay, so this is good. You don't have to isolate anything for this particular problem because over here in the first equation, y has been isolated for you, and it equals to all of this, right? It equals to all of this in green. Okay, so let me go ahead and write the first equation out. Y equals to negative 3x minus 8. Okay, that's the first equation there. Now, what we need to think about is, here's this y, right? This y is the same thing as that y there. So that means this part here in green, the 50 minus 2x, I can replace that with this y right there. Okay, so if I do that, I get 15 minus 2x on the left-hand side. And on the right-hand side, I get negative 3x minus 8. And now we get back to solving an equation here. So what I'll do now is I will take this negative 3x, move that over, and I'll take this 15 and move that over. So the negative 2x in orange will remain the same. And if I move this negative 3x to the other side, that becomes positive 3x. And then the negative 8 remains. And if I take this 15 here, which is positive, if I move that over, I get negative 15. Okay. And then I get a positive x there, right? Negative 2x plus 3x is just x. And negative 8 minus 15 is going to be negative 23. So x equals to negative 23 there. Okay, and then once we know that x equals to negative 23, let me just erase all this. It doesn't matter if you want to use the first equation or the second equation. I'll use the second equation right here because it just seems like the work that's involved takes fewer steps. So y would equal to 15 minus 2x Now remember, what does x equal to? X equals to negative 23. So let's go ahead and plug that in. So this is 15 minus 2 times what? Negative 23. All right, so that's what substitution is. That's called substitution there. So now you need to calculate negative 2 times negative 23, and that's going to be positive, is it 40, positive 46, I believe. So 23 times 2, yeah, 46. So 46, yeah. So then 15 plus 46 is going to be 61. All right, so my final answer is going to be negative 23, comma 61. Okay, let's move on to the next set of homework questions here. Let's move on to this one here. Okay, I got y equals negative 2x, and on the second equation, I have x plus 4y. So I recommend keeping this line here, and let's just rewrite the second equation over here on the side. So I have x plus 4y equals to 21, and then ask yourself, what does this y equal to? Well, this y equals to that y, so we're going to take this negative 2x and replace that with that y right there. So here is my substitution step. It's x plus 4. Now instead of writing y, what does y equal to? It equals to negative 2x. Now equal to 21. All right, and let's go ahead and just multiply this out, x, and then if I multiply 4 times negative 2 is going to be negative 8, so negative 8x. And then let's go ahead and collect like terms on the left-hand side. X minus 8x is going to be it's going to be negative 7x, and then you divide both sides by negative 7. And if I do that, I get x equals to negative 3. All right, so x equals to negative 3 there. And once we know that x equals to negative 3, let's just go back to the first equation here. So here's my first equation. I'm going to rewrite it. So I know that y equals to negative 2x. Now remember, what does x equal to? X equals to negative 3, right? So let's go ahead and plug in negative 3 there. So it'll be 2 times negative 3. And negative 2 times negative 3 is going to be positive 6, right? So my final answer is going to be negative 3, comma 6. Okay, great. Let's go ahead and do the next few questions now. So hopefully you're okay with what substitution is, and it's all about just eliminating the algebra steps. For this question here, let me take a look at the first equation here, and I noticed that I can probably isolate this t here. And if I isolate that t, I'm going to take this 2s and move it over. And move that over here. So if I do that, t would equal to negative 3. And this 2s right here is positive, so if I move it to the right-hand side, it becomes negative 2s. All right, so that's step number 1. You got to rearrange the first equation, and that's a common theme for a lot of problems in chapter 6. You got to rearrange the equations to have in the right form. And then on the second equation here, let me just rewrite this one just below here. I get 3s plus 2t equals to negative 4. And this t right here is the same thing as that t. And what that means is I'm going to take this orange box here, and I'll replace that with this t right there. If I do that, I get 3s plus 2. Now, I don't need a t now. I need negative 3 minus 2s. And that equals to negative 4. And after that, you can just distribute this. 3s minus 6 minus 4s equals to negative 4. Okay, and then let's go ahead and collect like terms again. Here's 3s minus 4s. That's going to be a negative s minus 6 equals to negative 4. And let's go ahead and solve for s here. I can bring this negative 6 to the other side. So if I do that, I get negative 4 plus 6. So negative s would equal to positive 2. And if I divide both sides by that negative sign, which is the same thing as divide by negative 1, I get s equals to negative 2. All right, so s equals to negative 2. And once we know that, once we solve for s, we need to go back to our original equation here. And let's go ahead and erase all this here. Let's go ahead and copy out our first equation again and use this to kind of solve for the t variable. So I have 2s plus t equals negative 3. Now we just noticed that s equals to negative 2, right? So you have 2 times negative 2, because s would equal to negative 2, and then plus t equals to negative 3. If I calculate that, I get negative 4 plus t equals to negative 3, and then t would equal to negative 3 plus 4, and then t would equal to positive 1. All right, so my final answer is negative 2 comma 1. So this is your s value, and this is your t value. Okay, let's keep on going here. Let's move on to letter N. 2x equals to 3y plus 4, and I have 6x equals to 9y plus 8. All right, so this is where the questions become a little bit more, they're getting harder now, because if I take a look at this first equation, I mean, what can you isolate for? Let's go ahead and just try to isolate for x here. So the equation is 2x equals to 3y plus 4. So if I isolate for x means get x by itself. I can divide both sides by 2. That means I divide this by 2 and I divide that by 2. If I do that, those 2's cancel off, giving me x equals 2. Now this part right here, this 3 and the 2, make sure you're okay with rewriting that as 3 over 2. And then the y can just remain, plus, and then 4 divided by 2 is going to be 2. So this is what x equals to. All right, now if I rewrite my second equation here, I have 6x equals to 9y plus 8. All right, that's my second equation. And I have an x here, and that x equals to this x. So I can take all of this, part in blue, and replace that with that x there. That's called the substitution step. So I do apologize that my writing isn't super neat here, but hopefully you can understand the concept that I'm trying to, the concept that's coming out of this. So there you go. That's how you substitute the 3 over 2y plus 2 into the second equation there. And that will give you 9y plus 8 on the right hand side. And now you need to distribute the left hand side. Okay, so in order to do that, I have a 6 here, and I'm going to distribute that onwards to here. There's a few ways you can do this. I mean, 6 times 3 is 18, and if you divide that by 2, you get 9, right? So that would be 9y plus, and then 6 times 2 is 12, so 9y plus 12 equals to 9y over here plus 8. Now this is really nice because if I take this 9y and bring it over, I get 9y here minus the 9y, and then whatever plus 12, equals to 8 over there. And you'll notice that 9y minus 9y is 0. So 0 plus 12 equals to 8. And then if the 0 remains, and if you move the 12 over, 8 minus 12 is going to be negative 4. Now, does 0 equal to negative 4? No. So this is a case where you have no solution. All right, we have no solution because we can't get the variable isolated. We have a number that does not equal to the number on the right hand side. So 0 does not equal to negative 4. So it's an incorrect statement. So there's no solution. Okay, finally, let's do this last question here, and then I'll create another homework video for the remaining questions here. Now, when you have a question with fractions, I recommend that you get rid of the fractions or get rid of the denominator. So there's a 2 and a 3 there, and on the second equation, there's a 4 there, right? So you have to be very good with getting rid of the fractions, right? So if you want to get rid of the fractions, look at the denominators. So for the very first equation, there's a 2 and a 3. What's the least common multiple between 2 and 3? Well, the least common multiple between 2 and 3 is going to be 6. So I'm going to multiply everything here by a 6. All right, so I would recommend doing division first. What's 6 divided by 2? 6 divided by 2 is 3, so I get 3x. And then what's 6 divided by 3? That's 2. And what's 2 times this 2? That's 4, right? So that's going to be minus 4y equals 2. And finally, what's 6 times 2? That's going to be 12. Right, so we do quite a bit of those exercises in class, so make sure you're good with removing the denominators by multiplying by the least common multiple. Now on the second equation here, I just have a 4 on the denominator, so that's going to be your least common multiple here, so that means you can times everything by 4. If I do that, 4 divided by 4 is 1, and 1 times x is going to be x. So again, x there. And then what's 4 times 3? 4 times 3 is 12, so plus 12y. And then what's 4 times negative 4? That's going to be negative 16. And there we go. My fractions have now been eliminated. And what you need to do now is you need to solve this kind of problem the same way that we approached some of the previous problems. Now, this is your first equation. This is your second equation, right? I think it's better to deal with your second equation because I can just move the 12y over. If I do that, I get x equals to negative 16 minus 12y. And once I do that, we can take this guy and plug it back into equation number 1. Now, here's the x here. That x is going to be replaced with all of this. That's the substitution concept. So if I do that, I get a 3. Instead of writing an x, I get negative 16 minus 12y, and then minus the 4y equals to 12. All right, now if I do that, let's distribute here. So now I have 3 times 16. So 3 times 16 is going to be 48, so negative 48. And 3 times negative 12 is going to be negative 36y minus 4y equals to 12. So I now have a negative 48. And then if I combine these two terms, so 36 and the 4, so that's going to be negative 40. So negative 40y equals to 12. And then from there, I can move the negative 48. And if I move that to the other side, I get negative 40y equals to 12. And now this will become plus 48. And 12 plus 48 is going to be 60. And then I have the negative 40y over here. And then finally, we're almost done for y. We divide both sides by negative 40. Those cancel off. Then y would equal to, those zeros cancel off. You get negative 6 over 4. And that's the same thing as negative 3 over 2. So after all that work, y would equal to negative 3 over 2. And I would recommend that we go back to let's go back to the first equation here. Let's go back to here. I'm sorry. Now I believe we established that y was equal to, this y value has a value of negative 3 over 2. So let's go ahead and substitute that in now. I have 3x minus 4, and y has a value of negative 3 over 2. And then this would equal to 12 on the right hand side. So we have 3x. So a negative and negative gives you a positive, so that's going to be positive. 4 times 3 is what? 12. And 12 divided by 2 is 6. So 6 equals to 12. And then we go ahead and solve this equation here. I get 3x. Uh, 12 minus 6 is going to be 6, and then divide both sides by 3, and x will equal to 2. Okay, so that's it for the algebra-based questions from 6.3. There's a few more theory-based questions which I'll try to get started. Let's just go ahead and take a look at some of the theory-based questions here. I have, if the system of linear equations has one solution, then what restrictions are on the value of k? Now remember, if you have one solution, remember, what does that look like? Here's your graph. One solution is something like this. If one graph looks like that, then one solution would look like that. So the slopes have to be different, right? The slopes have to be different. So this slope here is positive. This is a positive slope, and this is a negative slope. So if you have one solution, you just need to make sure that the slopes are different. So if knowing that, the first equation has a slope of 3, right? And the slope over here is k. So what does k have to be so that we have one solution? Well, the slopes cannot be the same, right? So this k value can be anything but 3, right? So if it equals to 3, then you're going to have more than one solution, right? Sorry. Yeah, if it equals to 3, then you're going to have more than one solution, and for this problem you want one solution, so you got to make sure that the slopes are not the same. So this k value can be anything but 3, right? It can't be 3 no matter what. If it's not 3, then you'll have one solution for sure. Okay, let's move on to letter B. So I think for letter B, we've determined that if you want one solution, the slopes have to be different. Okay, so for letter B, let's go ahead and write this in the form y equals to mx plus b. So if I do that, let's just bring the 5x over. So I have negative y equals to negative 5x plus 7. And then let's divide both sides by negative 1. If I do that, now we get y equal to positive 5x minus 7. Okay, so that's my first equation written in the form y equals mx plus b. Okay, after I do that, let's take the second equation and let's write the second equation in the form y equals mx plus b. So here's the kx, let's move that over. So I have 2y equals to negative kx plus 4. And then divide both sides by 2. And if I do that, I get y would equal to negative k over 2x plus 2. Okay, so I do apologize, that's just really not clear, so let me just kind of redo this whole question again. Okay, let's do letter B now. Now for letter B, the very first thing that you need to do is you need to write each equation in the form of y equals mx plus b. If I do that, the first equation would be y equals to, basically what I'm going to do is I'm basically going to interchange these two pieces here. So y would equal to 5x minus 7. So there's the first equation in the form y equals to mx plus b. For this, the second equation here, a little bit of work here. So here's the 2y equals 2. Now this kx here, let's move that to the other side. So it's going to be negative kx plus 4. And then let's divide both sides by 2. If I do that, I get y would equal to negative k over 2x plus 2. All right, so let me just box this. Let's box that. All right, so for this particular problem, if we're trying to find the values of k or put restrictions on k so that we have one solution, this question has to do with the slopes. So there's a 5 here and a negative k over 2. So if the slopes were equal, so here's my slope of 5 equals to negative k over 2. If the slopes are equal, then we could have infinitely many solutions or no solutions, but we want to make sure that we only have one solution, right? So if I go ahead and solve for k here, 5 times 2 is 10 equals to negative k. And then if I move the negative sign over, I get negative 10. So what we're saying here is if k equals to negative 10, the slopes are going to be the same, right? So we want the slopes not to be the same, so that means k can be any value except negative 10. Okay, so if the slope is anything but negative 10, then we'll have at least one solution there. And that's the idea with some of these theory-based problems for question number 2 and 3. In fact, I'll do maybe one more problem here for 3A just to kind of wrap up, and then that'll be it for this homework video. So in this question here, we want no solutions. So what has to happen to k to have no solutions, right? So if you have no solutions now, remember, what does that look like? It looks like this. This is no solutions, right? So you need the same slope, but you need different y-intercepts, right? We need different y-intercepts. So if I take a look at my second equation, we need to write this in the form y equals mx plus b. And if I do that, I get y would equal to, it's going to be 2x minus k. So just do a little bit of algebra there and make sure your second equation is y equals to 2x minus k. And then if I take my first equation and put that underneath, I get y equals to 2x minus 3. Now, if you want no solutions, the key thing is it's the y-intercepts, the k and the 3 here, right? These have to be different, right? Because as you can see over here, this and this are different, right? So in order to have no solutions, the y-intercepts have to be different. So if they were the same, you would write it like this: k equals to 3. That's having the same y-intercepts. So now we're saying that they cannot be the same, so k cannot be 3. All right, so I think questions 2 and 3, they're a little bit confusing, the theory part, so please ask questions in class if you would like me to repeat this.